Good afternoon. I'm an educator from Kepler Educations, and this is the 14th video or the 13th video I forgot of the POTD series. So, before starting with the video, I just want to remind our viewers of our targets, and that is 500 views, more than 100 subscriptions, 150 likes. Apart from that, anyone who is serious about their careers, anyone who is focused on their placements, I would invite you all to check out our website, Kepler Educations, Kepler22B. The website is. I will give you a go through of the website just for the sake of simplicity, because a lot of people are not coming into our website. So please come into our website, because here you will be able to learn things which you will require in your later stages of your placement scenarios. Sometimes if this kind of screen comes, it's just because the backend is asleep. I have made the backend fall asleep sometimes. I mean, render has made it appear actually. A problem of render, for those who doesn't know, is that render as a backend hosting service usually sleeps when, for a certain duration of time, no request hits this particular service. What render actually does is that render actually hosts the entire application of backend in a particular machine, which is known as a virtual machine. And in that machine, as and when requests hit the service that is running inside in that machine, I mean the IP address of the machine, I mean the service will obviously lie inside the machine, and it will have a certain IP which the machine will behave as the border router. So if nothing hits on the border router, that is the machine itself, after for a certain period of time, it will fall asleep. After it falls asleep, it will take some time to wake up when a particular request hits the particular machine. So this I will keep on in this format until and unless the crowd in our website increases. But as long as the crowd is way below satisfactory level, this particular thing has to be done to save costs from our side. I hope you understand. So in this website, you will be able to find a lot of courses, curriculums, and all. You can choose these courses. We will be starting these courses very, very soon. Perhaps next month, October, mid-October. In those time, we are deciding to start our courses. The first month will be provided free, or there will be discount. There will be a lot of discounts. The first month is free as for now. It will be. I mean, the discount might. We are planning to increase the discount for the remaining months. Or if you're not interested, you will, I hope, be able to solve problems that comes to our site. There are a lot of problems that are present in here. So these problems are curated based on the placement scenarios that are going on currently. The problem is that the coding platforms that usually is present in the market are based on all types of situations. But this particular sheet or coding sheet or SD sheet, whatever, this particular sheet, practice sheet, is curated in iterative fashion for different placement scenarios. Like for this year, it will be something. For next year, we will have something, and obviously these sheets will be available. All sheets for all the years will be available. So work is going on in this definitely, but as for now, this is a good enough place to start practicing in a CP oriented pattern, because that is something that interviewers these days are focusing on slightly. I mean, CP is not still in demand. It gives an edge. It gives an edge. So as I said before, jumping into all those. So if you are seriously interested, okay, before that, all our notes, as I told you, is present in here. I hope you all are seeing these. Along with that, I mean, apart from that, if you are interested in studying in Kepler Educations, then please, this group will be open to everyone. Please respond in this group. Anyway, please respond in this group. You will be able to do so, or you can definitely respond in our chat, in our YouTube chats. So anyway, before wasting any more time, without wasting any more time, let us dive into our video. So today's problem is reversing of a linked list. So we are given the head of a linked list, of a doubly linked list, and we have to reverse the doubly linked list and return its set. There are two approaches of solving this question. One is considering that this is a doubly linked list. One is not considering that this is a doubly linked list. We will solve it without considering that this is a doubly linked list, not just because we want to generalize this particular thing, but because solving this problem by considering this to be a doubly linked list will take much more time, not much more, but more time than solving this problem by considering this as a single linked list. Let me show you why. So let's say we have to reverse this particular linked list. Let's say we have to reverse only this particular linked list right now. So you see, if I consider this as a doubly linked list, let us consider this as a doubly linked list. And let us consider the time of a simple algorithm, how it is going to take, how much it is going to take. So you are given the head, right? You are given the head. So if you are given the head, you are not given anything else. You are not given the length of the linked list. You are not given the tail of the linked list. So the first and foremost thing that you will need to do is that you will put a pointer here at the head, and you have to keep moving the pointer by incrementing it. You have to keep moving the pointer. Until you find the last node. You have to keep moving the pointer. You have to keep moving the pointer until you find the last node. You see, at this position, PTR arrow next is equals null. So you will break up. You will break. If PTR arrow next is equals null, you will break. So this PTR becomes tail. Now, how will you reverse this particular linked list? You will put the head in here. You will put another pointer, let's say P here. This PTR can work. This PTR can work as it is, and you will swap them. You will swap them. So you will swap 1 with 6, and you will move P equal P arrow next. PTR is equals PTR arrow prev. PTR arrow prev. Then you will swap them. This D reverse swapped 6 and 1. Then you will swap them 2 and 5. Then P moves here. PTR moves here. Then you will finally swap 4 and 3. You will finally swap 4 and 3. And then P and PTR process each other. P and PTR process each other. In this situation, the iteration will stop. And you will return this particular head. So let us see how much time it takes. But before, let us write the algorithm first. So first is node star PTR equals head. While PTR arrow next. That is, it is true. PTR arrow next exists. Then PTR equals PTR arrow next. Then you will what will do? Node star P equals head. Then what will you do? While P arrow next not equals PTR arrow pre or something like this condition. What condition can you see? Let us check. Let us check for a generalized case. Let us check for 5 length. 1, 2. Let us see 3, 4, 5. So P PTR, and so P will move here. PTR will move here. And P will move here. PTR will move here. So this is for even number of length. 1, 2, 3, 4, 5, 6. What will happen? P PTR. P PTR. P PTR. So these are the two conditions that can exist. So it can become PTR arrow next. Next P PTR. After this it will become PTR arrow next equals P. This is the fourth step. First step, second step, third step, fourth step. This is the way P is moving. The steps are moving. This is the way steps are moving. So these are the four situations that can arise. So there are two conditions here. While PTR arrow next is not equals P arrow brief, or you can simply say PTR arrow next not equals P, or PTR not equals P. These are the two conditions. These are the two conditions. In fact, you can simply write it PTR arrow next not equal P, because after the situation, what will happen? We can swap 3 with 3. Doesn't matter. After the situation, PTR will come here and P will come here. So okay, PTR will arrow next will not becomes equal to P. Okay, so you have to keep these two conditions. While PTR arrow next not equals P or PTR not equals P, one of them can happen at a time. Both of them can simultaneously happen. So while these are not true, you will do what? PTR arrow next. So sorry, PTR arrow data. You will swap them. Swap P arrow data, comma PTR arrow data. This is one thing. Then you will do what? PTR equals PTR arrow prev, and P equals P arrow next. This is the entire algorithm, and at the end you will return head. At the end of the algorithm, what you will do? You will return head. So let us analyze how much time it is taking. This particular thing is taking a time of n, order of n. And this particular thing is taking a time of order of n by 2. So the total time that you are taking is that order of n plus order of n by 2, which is equal order of 3n by 2. The time complexity, the space complexity is simple. The space complexity is order of 1. So this is greater than 3n by 2. 3n by 2 is greater than n. So can we optimize the solution to order of n? Yes, we can, by considering this as a single linked list. So now the algorithm starts. We will convert it to an order of n algorithm, and that will be very simple. 1, 2, 3, 4, 5, 6. We will keep 3 pointers. This is the first pointer. Let's call it F. This is the first pointer. This is the second pointer. This is the third pointer. Now we will do a very simple thing. We have to reverse this linked list in the forward direction. First arrow next is second arrow next is third. But if you are trying to move in the reverse direction, what would a reverse linked list become? This will be the reverse linked list. In the reverse linked list, you see properly. 2 arrow next should be 1. 2 arrow next should be 1. You will just mimic this condition. 2 arrow next will be 1. You will just mimic this condition. You will make 2 arrow next will be equals 1. Okay, done. Now what will you do? You will increment them. You will increment first the first pointer. You see, there is now 2 arrow next becomes 1. So between 2 and 3, there is no further link anymore. Between 2 and 3, there is no further link anymore. So you have to move from 2 to 3. So how can you move the pointer? First, you move the F. First, you move the F to the second position. Let's make it F. Then what you do? Then you move the S to T, because this is the reason why I am keeping the T pointer, so that S can move. So S comes here. Now T equals T arrow next. T comes here. So S will move to 3 after this algorithm, after this iteration. So you see, this is the first, this is the second, this is the third. So what will happen? So you see, in the reverse order, 3 arrow next should be 2. So, but here in the forward direction, 3 arrow next is 4. So you simply make it come here. Okay, you see 3 2 1. This direction reverses. 3 2 1. This direction reverses. So what will you do? First, you will put F as here. You will move F to the next one. You will move S to T. You will move the second pointer to the third pointer, and T equals T arrow next, as before. So you see 4 arrow 5, 4 arrow 5, 4 is arrow next is 5, but 4 arrow next is supposed to be 3. So you will simply mimic this condition. You will make this condition. So 4 arrow next equals 3. 4 3 2 1. This becomes order in reverse order. Now again you will move 5. So this becomes, so you will move the first to the second. You will move the second to the present third, because between second and third there is currently no pointer at all. So you have to make the pointer go to the another pointer by keeping the second pointer intact, like not second pointer, but keeping the third pointer intact. So you need the third pointer for the second pointer to move to the third pointer. So you make it S, and now finally you move the T. You move the T. You had to keep the T. You had to keep the T here before you move the S, because if you had moved the T here to 6 before moving S, then S would have come. S would have directly come to 6. You have to prevent that, and that's why you are moving the T at the very end. So S comes here. Now it is safe to move T. You move T to here. Now you see, first is 4, second is 5, third is 6. In the reverse direction, 5 arrow 4 5 arrows next should be 4. So you make this condition. 5 arrow next comes to 4, and after that, you see, you do the same thing. Make the first come here, make the second come here, and there is nothing to go, nothing more to go, nowhere more to go for the third pointer. So the third pointer moves out of bound and comes here. So you see, in the reverse direction, 6 arrow next should be equal to 5. So you just make this condition. 6 arrow next becomes 5, and then what you do? Then again you do the same thing. You make the first come here, you make the second move to the next, to the third. Now third is already null. Third is already null. So after this particular iteration, the second, this particular second, where it goes? This second goes to the third, which is null. So second goes to null. Whenever second goes to null, you stop the iteration. And let us see what happens at this moment. Sorry, 1, 2, 3, 4, 5, 6. Carefully observe. This 2 arrow next was 1, 3 arrow next was 2, 4 arrow next was 3, 5 arrow next was 4, 6 arrow next become 5. Second has come to the position of third. Which is all null. And the first is still pointing at this particular node. Two things you have to observe. First is that 1 arrow next is still 2. So what will you have to do? You have to remove this particular node. And you have to make 1 arrow next equals null. That is head arrow next. This was already the head. Always remember, we use first, second, and third pointer. So this was the head from the very beginning. So this remains the head, and this remains the head. So head arrow next you will have to make null, and the new first pointer becomes the first. Is still the first. Is the first, because in the reverse direction, the first is at the last node of the forward direction. So the first is the last node in the forward direction. So first is the first node in the reverse direction. So you will have to return first. So let me code it up. It is a very simple code. The code is node star first equals head, node star second equals head arrow next. Now suppose it is a one length that is only the head exists. Head arrow next is equals null. So second doesn't exist. If not of second, there is nothing to reverse, because it is simply a single node linked list. So you will return head. Now the main thing starts. Now node arrow third. Why are we keeping third? We're keeping third so that we can easily move the second pointer to the next one. And between second and third, after we perform the operation, there is no connection at all. So you need the third pointer. Second arrow next. So while second, as I said, when the iteration ends, this second goes to null. The second goes to third, that is null at the end of iterations. So while second, what you will do? First thing is that you will make the reversal. The second arrow next, as we said, will become first. Second arrow next will become first. You see, second arrow next. See, second arrow next is second. This was earlier situation. You make this come here. Second arrow next, and this is first. So second arrow next becomes first. Now you make the movement. So first goes to second, as we saw. Second goes to, okay, you can also, yeah, you're right. Anyway. First goes to second goes to third. Can you write first equals first arrow next? No, you can't, because in the very previous step, if you are thinking about head, there is a special case. I will come to it, for which there is no previous case. So head arrow next, this particular first arrow next, you will have to make it null at the end of the algorithm. But in general, if this is the first, if this was the first, if this was the second, this was the third. General algorithm. Let us talk about two. First, second, third. At the first iteration, then 2 arrow next becomes 1, and then this 2 becomes first, 3 becomes second, 4 becomes third. At this step, what happens? There is no connection between 2 and 3. There is no connection, and there is no connection between 2 and 3. So first arrow next is 1 actually. So if in this situation, instead of doing first equals second, and if instead of doing first equals second, if you do first equals first arrow next, then first will move to its previous pointer. First will move to its previous pointer, and there is no point at all in writing first equals first arrow next. So you have to write first equals second, because you have to move forward. If you had written first equal first arrow next, you will have moved forward. This backward, you would have moved backward to the previous node. You have to move forward to the next node, and the next node is second. The second becomes third. Why? Because there is no connection after this particular line. After this particular line, there is no connection between the first and the second and the third pointer. So you have to write second equals third. And if there is a third, why if there is a third? Because you have to check if it is the last iteration or not. If it is the last iteration, then the next, the third pointer will be pointing at null, and first and second will be pointing at last and second last pointer, not respectively. I mean, last pointer is second last pointer is first, and third pointer is still null. So in that situation, if you try to move third equals third arrow next, you will get a null pointer exception. That is why you cannot send third equals third arrow next. So you have to check if the third exists or not, because if the third doesn't exist, there is no point in moving it. So third equals third arrow next. After the last step, second moves to third, second becomes null, iteration stops. At this situation, the entire linked list has been reversed except for this first node. So it is already head. First may be here, but it is head. Head is still maintained. So you will write head arrow next equals null. This particular next pointer you have to modify. So head arrow next becomes null. At the end, you will return first, because it is the last node of the linked list in the forward direction. Therefore, it is the first node of the linked list in the reverse direction. So this was the algorithm. So before going to time and space complexity, let me show you the code. So I've written the exact same code. So you will get the first pointer as head, second pointer as the next one to head, and if the second does not exist, that means a single length linked list. You will one length linked list. If there is no point in reversal, you will return head. Now the third will be the second arrow next. So the third node of the linked list. So while the second doesn't become null, so second arrow next becomes first. You have to reverse it. Till now, second arrow next was third in the forward direction. In the reverse direction, second arrow next will be equal to first. That you will have to make. Now, at this situation, there is no pointer between first and second. There is no pointer between second and third. So you have to jump them. So first becomes second in the forward direction, second becomes third in the forward direction. And if the third exists, that is, it is not the final step of the algorithm. If the third exists, then third equals third arrow next. Third will move forward. So when the third becomes null, it is the last step of the algorithm. You will make second arrow next equals 1. Earlier it was second arrow next equals null. Now it becomes second arrow next equals first. So sorry, second arrow next equals first. Yeah, right. So it reverses. Second moves to third, which is null. First moves to second, which is the last node of the linked list. And the second had moved to third, which is null. Second becomes null. This condition is violated, and the while loop stops. Now the entire linked list has been reversed, except for the fact that the head pointer still points to head arrow next, which is the second node of the linked list. So you have to make head arrow next equals null. You have to make head arrow next equals null, because this particular next pointer for the head has not yet been modified, and this should become null because it's supposed to. You can also write head arrow next equals head arrow pre, because in a double linked list head arrow pre is null, but we're not using the pre at all. We are not using the pre at all. See, head arrow next becomes null. The next pointer of the last node of the linked list becomes null. And you have to return first, because I said for the forward direction this was the last node, first goes to the last node. So in the reverse direction, first becomes the first node. Let us see if it runs or not. Yeah, it has run. Let us submit it. Yes, it has submitted perfectly. Alright, so let us now come to time and space complexity. Yeah. So these all are O of one conditions. These all are O of one conditions. If else, these all are O of one conditions. The only loop starts from here, and the loop goes the second moves. Let us say this is the linked list. The second moves, iteration ends. So this entire thing takes off n time. And here next equal and here next. These all are off one operations. So your time complexity becomes order of n. Space complexity becomes order of. If you are not assuming this, you are not considering the space of the linked list. So as I said, this entire notebook will be available on our website. In the library sections, resources, tabs, community library. So before before ending the video, I would request all of you to please at least watch the Kepler website, go through it. There are a lot of things present in the Kepler website that might help you with your studies. The fees to the course are also very less priced, so it wouldn't be a problem for anyone at all to purchase the courses. So this is all for today's video. Hope to see you in the next one. Thank you.